This is a simulation of gas laws to show the change of temperature, volume, and number of particles affects the pressure in a closed, inflexible container. Where my mouse is circling, the volume, temperature, and number of particles can be adjusted, and the collisions per second is labeled here. And the temperature and speed of each particle is also listed. The speed is a theoretical value if this were hydrogen gas and it was at its current temperature. If the volume is decreased, according to Boyle's law, the pressure will increase. And this is shown as the collisions per second are increasing. And when I set it back to its original value, the collisions per second will have been lowered. And if I increase the number of particles, the collisions per second will also increase. And once I sent that back to its original value, 50 particles, and adjust the temperature to be increased, then there will be more kinetic energy and more speed than in the particles, which makes it more speed, and more speed causes more collisions, and that causes more pressure. Therefore, there will be more collisions per second. And once I decrease the temperature, the collisions per second will also decrease, as in Gay-Lussac's law, temperature is directly related to pressure. And inside the box is another perspective that can be seen, where you can see the gas particles collide with each other and bounce off each other. And this is basically just a simulation of how changing volume, temperature, and number of particles, how that affects the number of collisions per second and the pressure in a specific box like this being closed and inflexible.